Hello everyone, welcome to this lecture video on Introduction to Design of Steel Structure. I am Shiela Balanta, Assistant Professor, Department of Civil Engineering, St. Xavier Catholic College of Engineering, Nagarkovil. Introduction to Steel Structure. Steel structure form the backbone of modern infrastructure due to their high strength, durability and ease of construction. From skyscrapers and bridges to industrial sheds and towers, steel is widely used because of its adaptability and efficiency in both structural and architectural application. Structural steel is widely used in making transmission tower, industrial building, bridges, storage structure, water tank, etc. From this, first we know that what is meant by steel structure. That is, what are steel structure? Steel structures are the framework composed primarily of steel components such as beam, column and trusses. Their notable features include high strength to weight ratio, ease of prefabrication and assembling, recyclability and sustainability, excellent resistance to dynamic load. And now the importance of steel structures are forward in construction for several reasons. Widely used in high-rise building, bridges, industrial facilities and warehouses. Durable and resistant to environmental stresses, facilitate quicker construction timelines, offer freedom in architectural and structural design. Here some of the objectives of steel structural designs are to understand the fundamental of steel structure design, to introduce the limit state method of structural design, to differentiate limit state method from earlier design method, to provide an overview of IS 800-2007, the Indian standard for steel design. And about design method in structural engineering, over the year, three major design philosophies have guided structural design. That is, first one is working stress method, ultimate load method, limit state method. In working stress method is one of the earliest and most traditional approaches to structural design. It is based on elastic theory and assume that the structure behave linearly under loads. Second method is ultimate load method. Here the ultimate load method are also known as load fact method is a structural design approach that ensures safety by considering the maximum expected load a structure may face during its lifetime. The third point is about limit state method. The limit state method is a modern and rational design philosophy that ensures structure remains safe and functional throughout their service life. It addresses both the strength of the structure and its stability under working condition. Therefore, we are using the limit state method for our structural design. Then about the main key features are interrupt partial safety factor for load and material, ensure both limit state of strength and limit state of serviceability are satisfied, recognize uncertainties in material property and loading condition, recommended in IS 800-2007 for steel structure. The type of limit state methods are limit state of strength and limit state of serviceability. In limit state of strength, ensure the structural safety against collapse, yielding, buckling, fatigue, etc. In limit state of serviceability, ensuring functionality by controlling deflection, cracking, vibrations, etc. Design philosophy on limit state methods are: first one is factored load. The factored load is that is equal to characteristic load into load factor. Then design strength, that is equal to characteristic strength divided by material partial safety factor. Then structural member are designed for worst case load combination. The main advantages of limb state methods are: first one is more economical and efficient than working stress method and ultimate load method, provide balanced safety and usability, recognize probabilistic nature of loads and material strength used in modern codes globally. Then about the disadvantages, slightly more complex in computation, required understanding of probability based design. Then code for structural designs are: the main code that is used for structural design in India, that is as that is first one is IS 800 2007, general construction in steel, that is limb state method. The main salient features of this IS 800 2007 are: cover structural members in tension, compression, flexural and combined actions, provide guidelines for bolted, welded and rivet connections. It includes the rules for design of beam, columns and trusses, specify material and load partial safety factors. Then other relevant codes are IS 875 part 1 to 5, load and structures. In this code all the loads are given, that is about dead load, live load, wind and seismic load, etc. Then next code is IS 1893 earthquake resistant design. Then IS 456 concrete design for composite member. The advantages of using these design codes are: that is ensure consistency and reliability in structural design, provide safety margins against uncertainty, help meet legal and professional standard, allow use of standardized load combinations and design actions. Here some of the structural members that is used for our structural designs are: first one is that is about types of structural steel section. Okay, here the structural sections come in various shape and size, that is each serving a unique structural purpose. The most common types are: that is rolled steel I section. Here the different pattern is there, that is ISMB, ISWB, ISLB, ISJB, that is it is one of the beam. Here the figure shows that the front view and the longitudinal direction of this beam section, that is used in beam and girder. Then high, it has the high bending strength. Second next type is rolled steel channel section, that is ISMC. Here also shows the cross sectional view and the longitudinal section of this channel section. Here the channel section is used in bracing frames and floor system, then suitable for edge beams and portal frame. The next case is rolled steel angle section, that is ISA. The figure shows the longitudinal and the cross section of this angle section. The angle section are equal and unequal angle. It have the equal and unequal angle, commonly used in trusses, towers and bracing systems. The next type is T section, that is IST, that is used where only one flanges is needed. Okay, here is also longitudinal as well as the cross section is there. The next type of structural member are square and rectangular hollow section, that is used in column, architectural application and the space frame. Aesthetically pleasing and structural efficient. About the square and rectangular section, here also it shows the cross sectional and longitudinal section of this square and rectangular section. The next one is circular hollow section, that is common in pipeline, poles and tower. The next one is plate and flats, that is used in the gusset plate, base plate and built up member. This plate and flats are used. The next case is about built up section, fabricated by welding together, that is multiple multiples of plate or section customized for heavy duty application. Here in the case of built up section, there is different sections are connected by using the welding or bolted connections. It is known as built up section. Here some of the figure is given, that is for I section. Here it is I section, that is top and bottom it is covered by the cover plate, that is by using the plate. Okay, then here the two I section is connected by the cover plate, and this section I and channel section, the I section at the top of the I section it is covered by the channel section. Here the two channel section is there, then two channel section it is connected by the cover plate. Okay, this type of this section, that is members, are called as a built up section. Then